Hey, how's it going, everybody? Welcome back. Today on Milanese Math, we're going to be taking a look at the sixth part in a series about the rules of exponents. And if you want to follow along with this worksheet, you can find it at the first link in the description below. So again, I'm going to assume that you have already watched the first 5 videos. If you haven't, I'll try to link those below as well. But you're going to really need to know that information for this to make sense, because otherwise this is going to seem a little overly complicated. But so a quick definition, if you want to remember a reciprocal, I just say it's the flipped version of a number. So the flipped version of a number. And I'll show you what I mean by that. There's fancier definitions, but that'll work for today. So it says write the reciprocal. Well, if you think of 2/3, 2 is in the numerator, 3 is in the denominator. The reciprocal, if we were to flip that or invert it, would be 3/2. You're literally just changing the positions. So the reciprocal of 2/3 is 3/2. The reciprocal of 7/4 would be 4/7. The reciprocal on number 3, the reciprocal of 1/6 would be 6/1. And sometimes you'll just see that rewritten as the whole number 6, because if you divide by 1, it doesn't change the value. So 6/1 or 6. Now on number 4, the number 19, remember technically this is 19/1. So that'll help you remember that the reciprocal is going to be 1/19. Okay, so if you have a whole number, just remember that it's over 1, and then when you flip it, it'll be 1 over that. Okay, so for the rule today, it's going to be a little bit differently. I'm going to show this to you a little bit differently than we did in the previous videos. Let's just do this fill in the blank. It says when an exponent is negative, we want to use the reciprocal and make the exponent positive. And I just want to walk you through what that looks like in an actual example. So it says when an exponent is negative, use the reciprocal and make the exponent positive. How about number 5? 2/3, and it's to the negative third power. So the rule says use the reciprocal. So the reciprocal of 2/3 is going to be 3/2. And make the exponent positive. So instead of -3, now it's +3. Okay? And you're done unless you can further simplify it, which this one we can. Remember, we can take this exponent and apply them to each. So 3 to the third power is going to be 27, and 2 to the third power is 8. Okay, so the rule today says if you have a negative exponent, flip it, use the reciprocal, and then just make the exponent positive. So for example, x over y to the -4th would be y over x to the +4th. We're just using the reciprocal and then make it positive. Okay, how about one like number 7? The reciprocal of that would be, let's see, c is going to be on top, a cubed b squared is going to be on bottom, and then this whole thing is now to the second power. Okay, now we're done, except that we're not done because we can apply one more rule of exponent. In this case, that 2 as the exponent on the outside is going to apply to each thing on the inside of the parentheses. So that c is now going to become c squared. The a to the third is now going to be a to the third to the second, which if you remember from your rules of exponents, you can just multiply. So a to the 6th. And then b to the second, 2 times 2 is 4. So b to the 4th power. Okay, so before these get too complicated, I'm going to have you pause the video now, and I want you to try numbers 8, 9, and 10, and then we'll pick up with number 11. So assuming you've had a chance to do that, let's take a look at what's going on here in number 11. We've got x to the 4th power over x to the 9th power. Well, if you remember from our previous rules, when we have a situation like that, we're going to keep the base, subtract the exponents. But this time, 4 subtract 9 is -5, which is correct, but it's not finished. And you kind of always want to think about that in a math class. If you have a negative exponent, you're not done. You need to simplify it. So what I'm going to do in that situation is use the reciprocal, which remember, technically, that's over 1. So to fix this, I'll use the reciprocal. So 1 now comes up to the top, and x to the fifth is going to go on bottom, but now the exponent is positive. Okay, so it's going to be 1 over x to the fifth. Okay, let's keep moving. Okay, how would I handle something like number 12? Well, I've got a's and b's. Okay, so let's just kind of do some thinking here. Okay, a to the fifth over a to the third. Remember, keep the base, subtract the exponents. So 5 minus 3 is going to be 2. B to the second over b to the sixth is going to be b to the negative fourth, right? Now, that's fine, like that's correct, you're just not finished because that b has a negative exponent. So think about it like this. Technically, that whole thing is over 1, right? So the a squared has a positive exponent, so he gets to stay in the numerator. That b to the negative fourth has a negative exponent, so he has to go from the numerator to the denominator. Again, the reciprocal, he has to flip his position. So instead of being in the top, now he's in the bottom, but his exponent is positive. Okay, so I did 2 things in that step. I took the b term from the numerator to the denominator, and I also simultaneously changed his sign because that's what the rule tells us to do, is use the reciprocal or change its place in the fraction and then make the exponent positive. Okay, let's take another look at another one like that. Really, honestly, here's what I tell my students to do is like, just draw your fraction bar. If you have a term like this, like it's got x's and y's and z's, do the subtraction, and if it's positive, you put it in the numerator. If it's negative, you put it in the denominator. Here's what I mean by that. Check this out. X to the 19th over x to the 6th. The rule says keep the base, subtract the exponents. 19 subtract 6 is 13. Since he's positive, he'll just go ahead and stay in the numerator. Y to the fourth over y to the second. 4 subtract 7 is negative 3. So you could put it in the numerator and then switch it down to the denominator and make it positive, or you could just go ahead and put it in the denominator from the get-go and make it positive. So again, let me just break that down real quick. Y to the fourth over y to the second, that was y to the negative third, which I could have put up here, but then I would have had to have switched him and made him positive. So instead of that, I'll just go directly to the denominator with it. Same thing with z, check that out. Z to the 10th over z to the 14th. What happens when you take 10 subtract 14? Well, you get negative 4. So if you really wanted to, you could put it right here, and then you'd have to remember to flip it and make it positive. What I would do is instead of putting z to the negative fourth, just in the very first step, I would put z to the positive fourth, but in the denominator. So just to zoom out in case that got confusing, when you have a problem that has like a bunch in the numerator and the denominator, do the subtraction. If it's positive, leave it in the numerator. If it's negative, put it in the denominator and make it positive. There's a few like that in numbers 14, 15, and 16. So go ahead and pause the video, try those, and then we'll pick up after that. Okay, so assuming you've had a chance to do that, let's look at numbers 17 and 18. These are gonna really combine a little bit of everything. These are as complicated as we're gonna go in this video series. So, oh boy, yeah, this is a big one here. So we've got x to the negative second, y to the negative first, the whole thing to the fourth power, x squared y over 2x to the fourth. Okay, there's more than one way to get where we wanna go with this. Here would be my recommendation. I wouldn't do too much in one step. I would just apply this fourth power to each one of these guys. I would call that x to the negative 8, y to the negative fourth. And again, all I did was multiply my exponents and then keep the rest of the stuff that's up there, x squared y, and that's all over 2x to the fourth power. Okay. Okay, so what should I do from there? Well, I could simplify some stuff going on in the numerator. So I've got an x to the negative 8 and an x squared. The rules there says to keep the base and add the exponents. So negative 8 plus 2 is negative 6. I could also combine those y's. I've got a negative 4 and a 1. That would make negative 3. And then the bottom is still the 2x to the fourth power. Okay, we're almost there. And let's see. Well, the the x to the -6 is going to have to go down into the denominator. So I'm running out of room here. Let me just show you here. This is going to be 1 over 2x to the 10th y to the 3rd. Okay, so that's going to be the final answer. Now, how did I get there? Because I kind of glossed over that. So I just don't want to make this too complicated here. The x to the -6 had to come down to the denominator because he had a negative exponent. So that made an x to the 4th in the bottom and an x to the 6th. I combined those into x to the 10th. The y to the -3rd also had to come down to the denominator, and so he's just left there by himself. So the only thing there wasn't anything in the numerator, we left a 1 there as a placeholder. That one was a little bit sketchy, but that's okay. All right, we've got one more to go, and then I think we're done. Again, these are as complicated as it could possibly get. So here we go. I'm gonna just start off by handling this situation first. Okay, I'm gonna apply that exponent of 2. Here we go. A to the 6th power, b to the 10th power, and then just copy down the rest of what you see. A to the 3rd, c to the 9th. And then if it's not too much, I'll go ahead and apply this 3 to these terms. So 2 to the 3rd power is going to be 8. A to the 2nd to the 3rd is going to be a to the 6th power. We've got b to the 12th power and c to the 4th power. Okay, so all I did was just clean up those that had each of the exponents. But now I've got a bunch of terms that need to be simplified on the inside. So I think what I'll do is I'll just simplify things in the numerator. For example, I see an a to the 6th and an a to the 3rd. Keep the base, add the exponents. So that's going to be a to the 9th. And then let's just kind of copy down the rest of it. Yeah, that's all I'm going to do in that step. I'm just going to go ahead and copy down the denominator exactly how we have it there. Alrighty, almost done. I think we can get there probably in one more step. So if I look at this, that coefficient of an 8 is going to have to stay down in the denominator. But what about the a? Well, a to the 9th over a to the 6th would be a to the 3rd, and since it's positive, I'll just leave it in the numerator. B to the 10th over b to the 12th, 10 minus 12 is -2, so I'll stick him down in the denominator and make him positive. And then the c, I've got c to the 9th over c to the 4th, which is c to the 5th power. And since it's positive, I'll leave it in the numerator. Now, the rest of these questions look mean and nasty. There's only 6 of them. I want you to go ahead and pause the video here and try these. And again, remember that each one of these rules of exponents isn't crazy complicated by itself. The hard part is when you're trying to remember how to do them when you're applying more than one rule at a time. But hopefully this video was helpful, and if it was, consider subscribing to the channel. And as always, thanks for watching, and we'll catch you next time.